Welcome back. Let's do question 9a. Right, in the diagram, alongside a circle passing through F, E, and D is drawn. Right, G is a point outside the circle so that FG is parallel to ED. It's already indicated there. And then DG is the tangent to the circle at D. Okay. Right, H is a point inside the circle with FHD being 90 degrees. It's already indicated there for us. So prove that triangle FED is similar to triangle GDF. So now I want us to just look at the information and try to fill in our writer here. Right, so what information do we get from this diagram and from the text here? What information do we get? I want us to discuss that before we do the proof. So you can highlight the triangles that you are going to prove if they are similar or not. So we have triangle FED and triangle GDF. And then we're told that FG is parallel to ED. Remember, when you're proving similarity, we can prove that the triangles are similar by proving that the corresponding angles are equal, or by proving that the corresponding sides are in proportion. Okay, so now we're told that FG is parallel to ED, so we're talking about geometry of parallel lines here, and then think of the alternate angles, corresponding angles, and co-interior angles, but co-interior angles are not equal. Remember, they are supplementary. So here we have alternate angles. If you check, this angle here is alternate to this angle here, since FG is parallel to ED. Okay, right. And then what else? We are also given that DG is a tangent. And then if you check here, we have a chord. So what you do to identify the tan chord theorem? Okay, you may have your own method, but this also may assist. Okay, you just draw or move from the outside of the tangent towards the point of contact. You move till you get to the point of contact, like this, okay? And then when you get to the point of contact, you follow the chord. You follow the chord, you see that? And then, so we have those 2 points at the end of of the chord there. Right, we have formed an angle here. If you check, we have formed an angle here. The tangent and the chord have formed an angle. And then from the end points of the chord, you form an angle at the circumference. You form an angle at the circumference. You see that? So it means these two angles are what? Are equal. That's the tan chord theorem. Okay? So now we are saying we have this angle, and then we have also, okay, let me use 2 lines here, and then we have this angle. So these two angles are equal because of the tan chord theorem, right? And then we prove that the two corresponding angles are equal. Therefore, the third pair also, this one and this one, are also equal. We say third angle of triangle. Then you're done. You see that we're going to prove that these two triangles are what? Are similar. Okay, now let's do it nicely. Let's start with triangle FED. In triangle FED and triangle GDF, right, we can say angle E is equal to which angle? This angle is equal to angle FDG. Okay, is equal to angle FDG. Right, why? We say this is the tan chord theorem. And then we have this angle D1 and angle F2. So angle D1 is equal to angle F2, because we have alternate angles. Alternate angles, then FG is parallel to ED. Okay, and then the third pair here, F1 and angle G. Okay, therefore angle F1 is equal to angle G. This is third angle of triangle. Okay, so now therefore we've proved that triangle FED. So now you have to be careful. F goes with G, so it's similar to triangle G. So F goes with G, and then FE, and then E goes with D. So then E there, second position, then D second position. And then with the last one, D goes with F. D third position, F will be third position. You see that? So we've managed to prove that triangle FED is similar to triangle GDF. This reason we say angle, angle, angle. Okay, that's what we're supposed to do there. Okay, we're going to meet when we do question 9b.